So now we're going to start section 13.4, which is about differentials. So we're going to start by talking about increments and differentials. And I want to start by recalling what we know from functions of a single variable. So recall back when we had y equals f of x, we would talk about delta x and delta y. These things are small increments of x and y. And delta y was given by f of x plus delta x minus f of x. And then we had the differential of y, which was given by dy equals f prime of x dx. Okay. So again, this is what you saw back when you first looked at functions of a single variable. And now let's talk about a function of two variables. So for example, let's say z is f of xy. And then we can talk about the increment of z, which is delta z, and it's given by f of x plus delta x, y plus delta y, minus f of xy. So this is the formula for delta z. And then from here we can talk about the total differential dz, and the formula for that, it's the partial derivative of z with respect to x dx plus the partial derivative of z with respect to y dy. So another way you could write this is it's fx dx plus fy dy. So there's my formula for the total differential here. And I will say that this is for a function of two variables, but you can extend this to a function of three or more variables. Your total differential will have more terms in it if you have more than two variables, but you can extend the formula. So let's practice trying to find this total differential. So find the total differential for each function. So we're going to start with the first function being z equals 2x sine y minus 3x squared y squared. While using our formula, I need the partial derivatives of z with respect to my two variables. The partial derivative of z with respect to x. So if I take the derivative of the first term, I'll get, with respect to x, it'll be 2 sine y minus 6xy squared. And then take the partial derivative of z with respect to y now. It'll be 2x cosine y minus 6x squared y. And now our total differential dz, it's that partial derivative with respect to x, 2 sine y minus 6xy squared dx plus my partial derivative with respect to y, it was 2x cosine y minus 6x squared y dy. And there is my total differential right there. Let's look at one more. B. Let's say my function is w equals x squared plus y squared plus z squared. So here, I'm looking at a function of 3 variables, x, y, and z. So now we need to take the 3 partial derivatives. So the partial derivative of w with respect to x, that will be 2x. The partial derivative of w with respect to y will be 2y. And the partial derivative of w with respect to z will be 2z. And then our formula for the total differential, here it'll be dw. It's the partial derivative of w with respect to x dx. The partial derivative of w with respect to y dy, plus the partial derivative of w with respect to z dz. And so now I just plug in these partial derivatives that I computed to get the formula for my total differential dw. It's going to be 2x dx plus 2y dy plus 2z dz. And there is my total differential.